One of the things that we want to be able to do when working with trig functions and with Pythagorean theorem is we want to be able to simplify square roots. We're going to introduce this topic now. You'll again work with it in Algebra 2, you'll work with it in pre-calculus, you'll work with it in calculus. So this is a concept that's very simple to understand, but it's also going to have far-reaching implications for some of your other math courses. So definitely something that you're going to want to take with you when you leave geometry. When we simplify square roots, what we want to do is we want to split this square root into two factors. We want one of the factors to be a perfect square root, and we want one of the factors to be a non-perfect square root. So when we talk about perfect square roots, those are numbers like 4 and 16 and 9 and 25. Those have square roots that are integers, whole numbers. So for example, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. And then the other factor is going to be a non-perfect square root. So what I like to do is I like to list out the factors of the number that is underneath the radical sign here. So we have 1 and 75, 2 does not go into 75, we have 3 and 25, we have 5 and 15, and I believe that's it. So I'm going to start with the biggest number here, and I just want to check to see if it's a perfect square root. So if I were to take the square root of 75, I would get a decimal. So we're not going to use this factor. And we don't ever want to use the factor of 1 anyway, because if you have a factor of 1 in the number here and you can get a perfect square root, it means that this number is a perfect square root. So I want to start with 25. If I take the square root of 25, I get 5. So we're going to take this. This is a perfect square root. So we're going to use these two factors here. And we're going to split 75 into these two factors. So we're going to put the perfect square root first. So 25 is the perfect square root. So we're going to put this here first. And then 3 is the non-perfect square root, because when we take the square root of 3, we get some weird decimal. So the last part we're going to do is we're just going to simplify each one of these if possible. So the square root of 25 is 5. And notice that when we take the square root of this number, the radical sign goes away. So if this number changes, the radical sign disappears. This number is going to stay the same, so we keep the radical sign with it. So our answer is going to be 5 square root 3. Notice I don't multiply these two numbers together. I can't, because this number isn't really 3, it's the square root of 3. It's representing a different number, kind of like x represents a different number. The square root of 3 is not 3, it's 1 point something. So I can't take 5 times 3 and get the square root of 15 or the number 15. I just leave my answer just like this. So let's try 48. We have 1 and 48, which we know we're not going to be using because 48 is not a perfect square. We have 2 and 24. We have 3 and 16. We have 4 and 12. And we have 6 and 8. There are a lot of factors of 48. So we know that we're going to get rid of this one. We don't ever want to use the factor with 1. So we're going to start with 24. If we take the square root of 24, we get a decimal. Now we're going to move down to 16. We just want to go down the biggest ones first, and then if we get to the bottom of these and we haven't found a perfect square yet, then we'd move to these and work our way up. So we always go from the biggest to the smallest. So 24 is not going to work, but we're going to check 16. So the square root of 16 is 4. So these are the two factors that we're going to use, because 3 times 16 is 48. So we're going to split this apart into two separate square roots, and we're going to put the perfect one first. So 16 is the one that has the perfect square root, so we're going to take this and put it under here. We're going to put the 3 under here, because square root of 16 times the square root of 3 is equal to the square root of 48. So now for each one of these, we just want to simplify. So the square root of 16 is 4, and the square root of 3 is just going to stay as the square root of 3. So now we have 4 square root 3 as our answer. Try 20. Go ahead and pause it. Give yourself a little chance to try this one on your own, and then come back to see if your answer is correct. All right, so I've listed the factors of 20, 1 and 20, 2 and 10, 4 and 5. And I know that I'm not going to use this one. So we're going to start with 10. If I take the square root of 10, I get a decimal. So I know that this is not the one that we're going to put under the radical first. If I take the square root of 5, that's not going to work. But since I've run out of all these numbers here, I'm now going to start over here, and I'm going to go up the list now. So I'm going to start with the biggest one over here and work my way up. So if I take the square root of 4, I get 2. So we're going to use these two. Now 5 wasn't a perfect one, so that's the one that's going to go second this time. So we're still going to split 20 into two different radicals. We're going to put the perfect one first, the perfect square first, and then the non-perfect one after. And then just simplify each one of those. So the square root of 4 is 2, and the square root of 5 stays the square root of 5. So we have 2 square root of 5 for our answer. And again, try 54 on your own, see if what you get is correct, and then come back and check your answer. So we're going to list the factors first. 1 and 54, 2 and 27, 3 and 18. Oops, had a brain stink there for a sec. 6 and 9, and I believe those are all the factors of 54. So again, we know we're not going to use the one that contains 1 and the number itself. So we're going to start with 27. If we take the square root of 27, we get a decimal. So we know that this is not the number that's going to go first. 18 will give us a decimal, so we know that that number is not going to go first. Take the square root of 9, and we get 3. So this is the pair that we're going to use. So again, break that into 2 separate square roots. We're going to put the perfect one first and the non-perfect one second, and then we're just going to simplify each one of those radicals. So the square root of 9 is 3, and the square root of 6 is going to stay as the square root of 6.